Good evening, centers. Shillong, good evening. How are you? Only Shillong has logged in till now. Yes, Shillong children, how are you? Very few I can see. Yes. Okay, so it's a very less number of children have come today. Yes. Why? Durga Puja. Okay, fine. So how was it? How do you celebrate your puja? Yes, Shillong. Excuse me. How was your Durga Puja? Good, nice. Okay. So we were doing a chapter that was excretory waste and its removal, isn't it? This puja is still going on. Today is 9th day of the puja, so puja is still on. So you can go back home and enjoy the rest of the left part of the puja, and tomorrow also, obviously. So we are going to continue with the chapter that is excretory waste and its removal. So we talked about many of the things, many of the topics we have already discussed, and we are supposedly going to start with the topic called as countercurrent mechanism. You won't give sweet? Yes, I wish I could. Okay, so tell me, how can I send you sweets? Tell me, how can I send you sweets? Okay, let me see, how can I? I will surely try to do. Okay. So we are going to continue with, and many of you have done homework, very good. I was very happy with many of you people, many of you who have done and posted that the same in the groups as well. So very good, keep it up. Okay, so we continue with the excretory waste and its removal. So do we have any doubts up till now, children? Do we have any doubts? Yes, tell me if you have any doubts, want to discuss something, or shall I start with the exact mechanism of concentration of the filtrate? So what we were talking about in the last classes we were talking about many things, like we talked about the urine formation process. The first process among the urine formation step was, the first was ultrafiltration of the urine, isn't it? Glomerular ultrafiltration. The next was tubular reabsorption, and third was tubular secretion. So when all these steps were taken together, we got the particular urine formation accomplished, isn't it? So I gave you a data where we talked about GFR to be how much per day? 180 liters, huge amount. And then I told you that urine is only excreted in terms of what? 1 to 1.5 liters only. Very small amount of urine is excreted. So what happens to the other parts? They are tubular reabsorption takes place, where they are reabsorbed and taking back into the plasma, so that you cannot lose so much of water in the form of urine, because we are terrestrial animals. We are in shortage of water. We cannot afford to lose that many amount of water. So basically the particular mechanism was glomerular filtration, reabsorption, secretion we did in a flat way. But what was the basic thing that made that possible? That ions were reabsorbed, the water was reabsorbed. What was the basic mechanism? The basic mechanism of concentration of urine. Start with mechanism of concentration of filtrate. So the basic mechanism that comes into account for this process is what? The basic mechanism for this process is counter current mechanism. So what do we have? We have a mechanism called as counter current mechanism, which is involved in this particular process. So let's write some introductory part about it. So what kind of urine mammals produce? We know mammals produce a concentrated urine. So mammals produce concentrated urine, and the concentration of urine is basically because of two parts of your nephron. That is the loop of Henle or Henle's loop, and what we have is vasa recta. Yes, what was vasa recta? Do you remember? Yes, children. What was vasa recta? What did vasa recta carry? What does vasa recta carry? Filtrate or blood? Yes, children. What do vasa recta carries? Filtrate or blood? Quickly. Yes. Who else is logged in? Yes. Which other center has joined us just now? Yes. What does vasa recta carry? Yeah, Senapati, good evening. How are you? What is vasa recta carrying? Quickly. It carries blood. If you refer to the diagram we did in the last classes, you will find out that there is a particular efferent arteriole, isn't it? Just refer to the diagram. You will find out an arteriole, efferent, E for elephant. Efferent arteriole which is just looping downwards towards the loop of Henle, and then it forms a whole networking. That networking part was called as peritubular capillary, and the peritubular capillary in the region of loop of Henle was called as vasa recta. So vasa recta obviously will always and always carry what? It will carry blood. Okay? Clear, everybody? So did we copy up to this? Can I move ahead to show you the countercurrent mechanism? Exactly. So this is what is the basic mechanism. This is the mechanism what we need to understand for the concentration of filtrate. How does the filtrate is concentrated? So we saw in the last class that what makes the filtrate concentrated. Now we are going to see how is the filtrate concentrated. Am I clear, children? Okay, I'm moving ahead. The next section will be obviously the countercurrent mechanism pattern, and we will discover how this pattern is working on. So we'll quickly draw the nephron structure. This is structure given in maximum of the board books. So be it your Mizoram board, be it NCRT, be it Meghalaya, all of them, all these state boards in fact, Arunachal and every board, they are given this kind of diagram. I'm just trying to sum up the types of the diagram in every book and give you a very good insight into the diagram. How is this following? Okay. Just draw along with me. We'll save some time. In the part where I need to explain you, I will ask you to pause. Okay. So where was efferent arteriole? Yes. Where was it? Where was efferent arteriole? Where was it? It was somewhere here. Look over here, everybody. All the centers. Shillong, Senapati. Just look over here. Just give me two minutes. Where was efferent arteriole? I used this kind of structure. Yes, where was efferent arteriole? This was efferent arteriole, isn't it? And how did peritubular capillary formation took place? Somewhat this way. Isn't it? Am I correct? This was vasa recta, the red thing, isn't it? Remember? Okay, now what I'm going to do is, I'm just going to pick up the vasa recta from this part and place it on this part of the page. Just nothing. I'm just going to pick it up from this section and put it on this part of the page. Clear? Everybody? Am I clear? All of you? I just picked it up from this section, from this part and this part, and just lifted it and placed it on the sides of the pages, this part and this part. Clear? Very good. So let's see what can be done. So I'm just removing this section now because I've already placed it on the left side. So I don't need this part now. Okay. Okay. Fine. Okay, just a minute. I need more of your time. Okay. The flow of filtrate in this part is to which side? Anybody? This side? Is it? Downwards? The flow of the filtrate in this side is towards upper, isn't it? Vasa recta in this section, this particular part, on the has flow of blood on this side. Just let me know if you don't get anything immediately. And the flow of blood in the vasa recta is towards this side. Is it? Yes? Yes, it is. I'm going to name these parts. This would be my 1. This would be 2, 3, and 4. Now let's see what does this 1, 2, 3, or 4 stand for. 1 is what? Yes, what is 1? This is descending limb of vasa recta, is it? I'm sorry, loop of Henle, really sorry. This is descending limb of loop of Henle. What is 2? 2 is ascending limb, a limb of LOH, loop of Henle. Clear? What is 3? 3 is descending limb of what? Vasa recta. 4, again ascending limb of what? Vasa recta. Tell me if anything is not clear. Diagram is clear? Copy the diagram. Just let me know if anything is not clear. Shillong, Senapati, everybody among you. Yes. Okay, very nice. Did you copy the diagram, everybody? Did you copy the diagram? Okay, very nice. Now I want to do some more corrections. Okay. Done? Everybody? Okay, I'm proceeding. Now what we have studied that our blood, now this is what is a particular kind of system called as counter current mechanism. Can you see this? Now the flow of fluid, we will just look at these diagram. The flow of filtrate in this section is just opposite to this. It's just like a traffic running on the road, isn't it? If you have a 2-lane road, the traffic would be running in the same way. One of the section will be moving to this side and other will be coming from that side, isn't it? This side and that side. They will be, one will be going to this side and the other will be coming from that side. This is what is counter current. Since it is a fluid, it would be said to be current. Otherwise, counter always means reverse. Now this thing, let's see this part. Okay, this part has again the flow of the filtrate in opposite to what part? Which part? Obviously this part. So we can see that there is a particular mechanism established between which parts? Let's see, between 1 and 4 and the other section is 2 and 3. So both have what? First and fourth, they have their independent counter current mechanism. And 2 and 3 have their independent counter current mechanism. Clear? Just let me know if it is clear or do I need to? Shall I explain it again? Just let me know. Okay, Senapati, where are you children? Are we connected? Okay, now what we have is the next thing. Now you have to learn 1 or 2, 3 things. Now what is the main thing? See, now your blood has an osmolarity. What is osmolarity? We have discussed this thing. Osmolarity is the fluid, water and iron concentration in the particular solution. So your blood has an osmolarity of how much? Your blood has an osmolarity of 300 milliosmol per liter. 300. So your blood has an osmolarity of how much? Your blood has an osmolarity of 300 milliosmol. This is unit of osmolarity per liter. 300 milliosmol per liter is the osmolarity of your blood. Now the things coming in the glomerulus. What are things coming in the glomerulus? That is blood. It has an osmolarity of 300. When they come down in this section, Bowman's capsule, they have the same osmolarity of 300 milliosmol. So we would call our filtrate over here in the Bowman's capsule to be isotonic. Iso means same, tonicity refers to the osmotic concentration. So they are isotonic over here. Just pay attention, this is a bit of tricky section, just pay attention everybody. Now, when they turn down to this part, there is actually loss of water, loss of ions, both the things. So what do we lose from this section? We lose water as well as ions. So when there is loss of both the things, water as well as ions from a particular part, will retain the osmolarity. If there is only loss of water, the osmolarity will increase. A similar thing, kind of thing, if I am giving you a salt solution to evaporate. Okay, so you are losing water from that. So the remaining salt solution will be more salty. So keeping that in mind, here we are evaporating both the things. We are evaporating water also, removing, not evaporating, we are removing water also and ions also. So that is going to maintain the osmotic balance of 300 in PCT as well. So your PCT is also isotonic to your blood plasma. Everything is in comparison with your blood plasma. So the filtrate present in PCT is isotonic. Isotonic means it has a similar concentration osmotic value as compared to your blood plasma. Your blood plasma has an osmolarity of 300 milliosmol per liter. And same is with Bowman's capsule as well as PCT. Now what happens in DCT? Remember, DCT starts to lose water. Descending limb of loop of Henle starts to lose water. See, if I am evaporating water from a salt solution, what is going to happen? The osmolarity will increase or the concentration of ions will increase. So this makes the concentration of ion to increase, like 300 will increase, start to increase. How? It will turn to 400, 600, 800, 1000 and then 1200. 1200 is the limit. Now when we move upwards toward the ascending limb of loop of Henle, what happens is, we have studied this thing, what happens? We start to lose NaCl. That is, NaCl is reabsorbed. So now if you remove ions from a solution, what is going to happen? The solution will become what? In this section the solution was what? This section was hypertonic. Hyper means concentration is very high. So 300 is always lower than 400. 400 is always lower than 600. Similarly, 1200 is always higher than 300, 400, subsequently all those values. So NaCl starts to move out, starts to get reabsorbed. So what is going to happen? We have 1000, the osmolarity starts to decrease. Or we can say the loss of Na plus will make the solution more dilute. 800, 600, 400. So dilution will start to occur. So this is a particular section where what we have is, we have the solution to be hypotonic, PO. Now, let's come to DCT. Now DCT is what? DCT is all about H2O loss and NaCl loss. So just now I have told you, if you are losing both the things, water as well as ions, the osmolarity will be what? The osmolarity will be isotonic. Am I clear up to this? Everybody? Shillong, Senapati, yes children, tell me. All of you, just give me a thumbs up if it is clear to everybody at Shillong Center. Yes. Okay, there is some problem I guess in the internet. Okay, nice, very good. Anybody who needs an explanation once more? Okay, very nice. Does anybody needs an explanation once more? Okay, fine. Is it a thumbs up or an explanation? Okay, I guess we all have understood. Now this particular part starts to lose water. Isn't it? So when it starts to lose water, okay, explanation. Okay, just a minute. Just let me finish this section. Okay, so when it starts to lose water, it will again become what? More concentrated. How much more concentrated? Let's see. This is going to become 300. Since it is isotonic, it will be 300. Then they start to lose water again. Again, my concentration is going to increase. The osmolarity will increase, turn to 1200. So at the end of the whole process, just a minute, I will come to the explanation part. So at the end of the whole process, the filtrate what you are removing out is how much? It is 1200. Okay, sorry. Just removing that highlight. Pink one. Pink section. Okay. Now this highlight is difficult to erase also. See? I'll rewrite it. Okay, so can I use a marker of different color? That I guess would be more easy. Okay. So explanation section. Okay. Now if I am giving you a salt solution, okay, I just gave you a salt solution. I dissolved 1 teaspoon of salt in 1 glass of water, and I'm now giving you to do what? To evaporate it. So there will be more of salt in the water, in the particular solution at the end of evaporation, yes or no? How many of you agree that there will be more of water after more of salt after evaporation? Can we call that solution to be hypertonic? Yes, I can. So hyper is something which is more concentration. Hyper means more, and hypo means less. So if I am giving 2 students salt solutions of equal osmolarity, now I've asked one of them to evaporate it, and other of them, the next number 2, I'm asking them to put 1 more glass of water into it. So what would happen? Student A will have a hypertonic solution who is evaporating it. The water is evaporating, the salt is having more of concentration in the particular glass. So the student A will be having a hypertonic solution. On the other hand, student B, who has mixed 1 glass of water in the salt solution, he or she will be having hypotonic. Hypotonic means, HYPO means it is of less concentration or it is very highly dilute. Am I clear? Everybody? So what is happening over here? This 300 milliosmol we started with. This is the particular concentration of the blood plasma. So when you are purifying everything, you are getting out everything in the same concentration as the blood plasma has. The blood plasma has certain osmotic balance maintaining constituents. Same constituent comes out in the Bowman's capsule. Now what we do is that we absorb water and we absorb ions from this section of PCT. Okay. So when you are absorbing both water and ions, what is going to happen? You will be getting a solution which is isotonic, because what you are doing, you are absorbing both the things. Okay, when you are absorbing both the things, I am taking away both salt and water both from you. And give me half glass of this water, what you are already having. You will be left with the same isotonic concentration, isn't it? Nothing much, nothing low. Then the same thing is happening in PCT as well. What you are doing is same thing, water and ions, same. Now in descending limb of loop of Henle, what are you doing? You are selectively moving out water. You are evaporating water from the salt solution. So you will be left with the solution which is more salty. So we will call that to be what? We will call that to be hypertonic. Okay? Next, from the ascending limb of loop of Henle, you are doing what? You are reabsorbing NaCl only. So this solution is becoming what? This solution will have more of water content. So I will be telling this to be hypotonic. Why? Because you are selectively taking out salt from the salt solution. So the particular solution will be less salty now. In this section, when we move to DCT part, we are removing both the things. Can you see? Water and ions, NaCl. So if I am taking half a glass of water and ions from you, you will be left with what kind of solution? Isotonic. Similarly, the collecting duct also removes selectively water. So you are left with what? More salty solution. So it is hypertonic. Now let me know if anything is not clear Is it clear? Yes. Clear, children? Very good. Everybody. Okay. Then this one section. This is the first part. This is the first part, and the osmolarity decreases and increases in the same pattern as we have marked. Copied up to this? Just make sure you're copying up to this. And let me know if you have copied up to this. Shillong, Senapati, have you copied up to this? Okay, very good. Okay, next section, let's move to the next part. Now everybody will look over here. Now what we had a perception earlier, see, this part 2 and part 3, everybody over here, look over here, everybody. This part 2 and part 3 correspond to each other. Correspond means what? The flow of filtrate and blood in these two sections are in opposite direction. That is, one is moving upward in 2 and one is moving downward in 3. So what is going to happen now? So this part where I have placed my second section, second part, I will be removing the highlight once I am just done with explanation. So this is the second part. I will remove highlight. Just let me explain once. So this is the part 2 of the nephron and this is the part 3 of the vasa recta. So both of them have a flow of filtrate just opposite to each other. I explained you this is called as counter current. Since it is a fluid, it is current. Since they are moving in opposite directions, that is called as counter mechanism. So what is going to happen now? Every time we are having a scenario that NaCl is getting deposited in this area. Okay. So if there is more of NaCl in an area, it is obviously going to attract water from the neighboring areas. This is osmosis. You only made me clear in the last class. Osmosis is what? Wherever NaCl concentration is high, water will move towards that area. This was simple osmosis. That is movement of water from its lower concentration to its higher, from its higher concentration to its lower concentration. So water is high in this area. Where water is high in this area now, we take into account, water is more in this third part. So what would happen? That water is going to come out from this area, from this section. Why? To equilibrate the ionic concentration in the nowhere region. Nowhere region means in the region of interstitium. So water is coming out for balancing because this NaCl was there. So this NaCl is actually creating a high osmotic gradient in the middle areas. So what is done? The particular plan what we have is we will remove we will remove water plus we are going to put into them NaCl. So you are going to do two things. You are going to take out water and you are going to put NaCl into it. I am removing the highlighters. So what is going to happen? Since NaCl is more outside, We'll put NaCl into it. Since water is less outside, we will take out water from this. Okay, so what are you going to do? You are going to put NaCl back into the vasa recta and you are going to move out water. So if the osmolarity of blood was how much? 300 milliosmol per liter. So when I started to put NaCl, the osmolarity will what? Increase. It will go to 400. I'm again removing water. This will increase further the osmolarity to 600. I am removing water. So water removal is what? Water removal will make the solution more concentrated. And the concentration will keep on growing till 1200. Now, next section is what? Next section is the filtrate has this particular part, the descending limb of loop of Henle. The ascending limb of loop of Henle, vasa recta, that is this section now. Let us look this part now, 1 and 4. So what is happening in 1? 1 is removing water. Can you see this? All these parts. What is 1 supposedly doing? 1 is removing water. See. So obviously this section corresponds to this part. So 1 is removing out water. So 4 has supposedly to take up that water. And moreover, 4 is in a condition also to take up water because its osmolarity is very high. So 4 has to take up water which has been released by. So what is going to happen now? There is going to be absorption of water by 4 that has been released by 1. So if I am putting water in the salt solution, what would happen? It will become more and more dilute. 800 to 600, 600 to 400 to 300. Okay. So what you have now is, you have the particular solution, you will get it back. So you started with a blood with a concentration of 300 milliosmol per liter. And we ended in the same situation, but the advantage was what? I took up all the extra NaCl, I took up all the extra water, which was released by the consecutive or the particular vessels present in these areas. That is NaCl of this area. So this 2, whatever 2 is releasing, this is absorbed by which part? This is absorbed by 3. And whatever 1 is releasing, it is absorbed by 4. Clear? Am I clear, everybody? A bit of hodgepodge diagram, I understand. But yes, we don't have an option for now. We need to refer to this diagram. Okay. Did you copy everything? Senapati, clear? Shillong, clear? Did you copy everything? We'll write a short note out also after this. Done? Okay, so let's write down something. So this was, let us write down. Okay, counter current mechanism. Suppose this question comes to you in your exam. How to handle it? And this is important also, this often comes for 5 marks. 5 or 3, either of them. So it's easy, very easy. So counter current means what? First of all, you need to explain this. There is flow of filtrate and blood in opposite directions giving rise to countercurrent. Parts. First part is descending limb of loop of Henle. Second part is ascending limb of loop of Henle. Third part is descending limb of vasa recta. Fourth part is ascending limb of vasa recta. A countercurrent mechanism exists between 1 and 4 and 2 and 3. Osmolarity in Bowman's capsule plus PCT is how much? 300 milliosmol per liter, which is equal to osmolarity of blood. So, Bowman's capsule and PCT are said to be what? Are said to be isotonic with blood. Isn't it? We had used this term, that is, both of them are isotonic with the blood. So, let's mark it important. Next section in descending limb of loop of Henle. Water starts to get reabsorbed, leading to increase in ionic concentration of filtrate. So if the ionic concentration of the filtrate increases, look over here. If the ionic concentration of the filtrate increases, what would happen? What's going to happen? Proximal convoluted tubule. PCT is proximal convoluted tubule. So, leading to increase in ionic concentration of the filtrate, this makes it what? This makes the filtrate in DCT to go hypertonic. So, if you remove water, what would happen? The filtrate would be hypotonic. Now, this was the descending limb of loop of Henle. And the filtrate moves to ascending limb of loop of Henle. What happens is NaCl is reabsorbed Now this makes what? This makes the filtrate hypotonic. So it's more dilute. H5PO, hypotonic. Next, the filtrate comes in DCT where you reabsorb both, just like the PCT section, proximal convoluted tubule. This is distal convoluted tubule. So if you refer to the lectures, the previous classes, you will see this. We have explained all these things. So both of them are reabsorbed, and this makes the filtrate again what? If both things are reabsorbed, what? Isotonic. Any confusion up till now? Let's come to collecting duct. So what is happening in collecting duct? You are reabsorbing water. So when you are reabsorbing water, what is going to happen? The filtrate will become hypertonic. So we started with an osmolarity of how much? We started with an osmolarity of 300. Remember, I told you Bowman's capsule and PCT, they have an osmolarity of 300. By the end of the whole process, when the urine comes in, so collecting duct is the part where you are going to refer to term urine. Not before than that, you can call it to be urine. Before then, this section, it is called as filtrate. Okay? So when collecting duct comes, when the urine comes in collecting duct, we find the osmolarity to be 1200 milliosmol per liter. So this whole process is actually going to make the filtrate more and more concentrated. How much? It's 4 times more concentrated So mammals, they produce hypertonic urine. What kind of urine produce? Mammals are producing, see this opening statement, we produce a concentrated urine, isn't it? This is the opening statement we had. We produce a concentrated urine. How much concentration? It is concentrated, it is 4 times compared to your blood plasma. Okay? So this is one of the parts. We have done one of the parts where we told that yes, how urine becomes more and more concentrated. Now, whatever has been left by the descending and ascending limb of loop of Henle, we have to remove those things. They came, they deposited, we have to take away. So now for the descending limb of loop of Henle, first of all, you can start it from either ways. We can start from ascending also or descending also. So first of all, let's see descending limb of vasa recta. That was, I guess, third part. So this has how much osmolarity? Has 300 milliosmol of osmolarity. Now what would happen? This descending limb of loop of Henle starts to reabsorb NaCl. Okay, and water moves out. So you are taking into NaCl and you are removing out water. You are doing two things at the same time. Which is going to do what? Which is going to both the things. Just imagine you are just putting NaCl into a salt solution and you are taking out water also from that salt solution. So obviously what is going to happen? The osmolarity of blood in where? in descending limb of vasa recta increases. So whatever blood you are carrying in the descending limb of vasa recta, the osmolarity of the blood is going to do what? The osmolarity of the blood is going to increase. So is it of any benefit to us? Yes, it is, because we have to, I'm writing take away, okay. Starts to take away NaCl and water moves out. Okay. Increases osmolarity, we can refer. You have drawn the diagram. See. The osmolarity increases. What we are doing? We are taking into NaCl and we are moving out water. So you are removing water and putting NaCl into it. Now next section is what? Next is ascending limb of vasa recta. What does happen over here? Yes, starts to take water into it, and therefore the osmolarity of blood decreases back to 300. This is excretory waste and its removal. Chapter number 19 of your book. Okay, I guess you were not there in the last class, Senapati, is it? Yes, because the last class I was only having Shillong Center. So you people have missed your last class, that's why you must be having some or other problems. But yes, you can refer to the videos. That would be helpful. Okay, are we clear up to this? This countercurrent mechanism is done. This was a big part. Is it understood by everybody? Yes. Okay, very good. Senapati, are you able to understand a bit of this? I guess this is the complex process, and since you were not there in the last class, this must be more difficult for you. But yes, are you getting something? Everybody? Yes. Sorry. No, you're not able to get anything. Oh, really sorry. Okay. This is because you were not present in the last class, children. That is the main reason. You were not there in the last class. That is making it a bit of more difficult. Yes, I'm really sorry about it. But I hope so. I will try my best to make you understand. But however, you need a background about these things to understand the higher complex levels. So I'm going to finish this chapter today. So this is going to be a bit difficult for you, I understand. Okay. So we'll look into the next topic, that is regulation of kidney function. So the regulation process is actually a bit of complex process. It has 3 different sections that we need to understand. Okay. So first of all, we all know that there is a hormone called as antidiuretic hormone. Now, this is regulation number 1 mechanism, first regulation mechanism. So what happens is this ADH, these are basically a kind of hormone which is released by posterior pituitary. Your pituitary has 3 sections. This is something new, Senapati. You can just learn these things. Try to understand. This is something new. Okay. Shillong Center also does not know about it. So, antidiuretic hormone is released from the posterior pituitary. The function of ADH is to reabsorb water from DCT and collecting duct. So what does it do? It reabsorbs water from DCT and collecting duct. Look over here, this section, this part, this parts. This is DCT, this first section up to here, and then we have this whole sections is called as DCT. Sorry, seat collecting duct. So this is going to reabsorb water from this whole yellow highlighted region. But the question is when it is going to do so. Reabsorb water when the plasma volume is low. So whenever the plasma volume is low, what happens is this starts to reabsorb water from DCT and collecting duct. Let's see the mechanism once again. So first let's start with low plasma or blood volume. This instigates the posterior pituitary to release ADH or antidiuretic hormone. ADH goes and acts on the DCT plus collecting duct, starts to reabsorb water. This reabsorbed water will ultimately increase the plasma volume. Okay. And this increase in plasma volume is going to increase the blood pressure as well. So this is the first mechanism by the help of ADH, antidiuretic hormone. Clear? Copied? Yes, Shillong, Senapati. Senapati, completed? Clear with this? Everybody? Okay. We'll have a small break, 5 minutes, and we'll resume with the second regulatory mechanism. This was only one of the parts. We have 3 mechanisms. This first part, we'll continue with the second part of the regulatory mechanism after a small break. That would be obviously called as renin, angiotensin, Okay, we'll continue with this thing. Yes, centers, can we resume? Okay, fine. Okay. Now we are going to continue with the renin-angiotensin system as discussed before the break. So now we know a term called as GFR. Okay, we have discussed a term called as GFR, that was glomerular filtration rate. How much is what it was? It was 125 ml in a single minute, and if you compile for the whole day, it came out to be 180 liters per day, isn't it? Now if suppose the GFR is decreased, somehow the GFR starts to decrease, so what is the particular mechanism that would be acting to increase the GFR? Because obviously if GFR is decreasing, that's a disorder, that's going to be a very, very big problem. So if GFR is decreased, what is going to happen now? So let's see. We are having a redoll structure of the nephron. Sorry. So we know that around about 1 million nephrons are present in both of your kidneys. So what happens actually, the structure of nephron I have taught you like this, isn't it? Simply this efferent arteriole, this makes a loop around the vasa recta and also all those things. But yes, I would like to mark one more point over here, this thing. This afferent arteriole, that is the arteriole which goes inside the glomerulus, this makes a contact with the DCT, that is distal convoluted tubule. Now let's see what is going on over here. If you just take a bigger version of this thing, somehow so this is what? This is the afferent arteriole, this is the DCT. So it's a point of contact, and this point of contact is actually having, read all this, this point of contact is actually having some special cells called as JG cells. That is juxtaglomerular cells, and the whole setup is called as juxtaglomerular apparatus. That is called as JGA. Now, the function of JGA, what is the function of JGA? Now, JGA can sense a decreased GFR. How? Because the blood which is carried to the glomerulus, that is for the purpose of GFR, glomerular filtration, is via the afferent arteriole. So, this can actually sense a decreased blood pressure. So, we will take into account if there is a decrease in GFR, that is equivalent to decrease in blood pressure as well. Decrease in GFR, decrease in blood pressure are the same things. If the blood pressure is high, GFR would be high. If the blood pressure is low, the GFR would also be low. So what they can sense? A decrease in BP or a decrease in GFR. And what they do is that in response to which they release in response to a low BP or a low GFR, JGA releases a hormone called as renin. Now this renin is actually a factor required to convert your angiotensinogen into angiotensin 1. This angiotensin 1 is further converted into angiotensin 2. Now the main activity of bringing up GFR or accelerating the GFR will be done by angiotensin 2 in a twofold mechanism. Number one, angiotensin is a vasoconstrictor. So we have done these all things. Now you know what is a vasoconstrictor. Vasoconstrictor. So what it does is, it makes your blood vessel narrow. So if your blood vessel was thick earlier, it will become narrow. So if it is narrow, what is going to happen? Obviously the BP is going to increase, because just remember a hose pipe. If you press the opening of the hose pipe with your fingers, the rate of water flow from the hose pipe is always going to increase. This increased BP is ultimately going to give what? Give you a increased GFR. The second role what it does is, this goes and acts on the adrenal cortex. Again a gland, and makes it to release a hormone called as aldosterone. This aldosterone does what? This reabsorbs NaCl and water from DCT. If you move back and see, this section, this part, the water removal from DCT and NaCl removal from DCT. This is by what hormone? This is by the help of NaCl. Aldosterone. So when you reabsorb water and ions from NaCl, this all water and ions are going into what part? This is going into the blood part. So this increases again the blood volume. So if you add water in the blood, it will increase the blood volume. If you increase the blood volume, automatically your blood pressure is going to move high, and if your blood pressure is going to move high, obviously what is you going to get? You are going to get a higher GFR. Once again, let's see the whole mechanism. First thing, what is happening? We are having a low GFR. Low GFR or decreased BP, same thing. Both are vice versa. So this is what is juxtaglomerular apparatus formed between the afferent arteriole and the DCT. DCT and afferent arteriole, they make a point of contact, and the special cells are called as JGA cells, juxtaglomerular apparatus. The specialty of these cells is what? They can sense a decreased BP or other ways a decreased GFR. And they start to release what? They start to release a hormone called as renin. This is a hormone. This hormone is responsible for converting the angiotensinogen into angiotensin 1, which further gets converted into angiotensin 2, which has a two-way effect. Number one, it increases blood pressure by vasoconstriction of the blood vessels. Number two, this acts on adrenal cortex and starts to release aldosterone, which reabsorbs NaCl and water from the DCT, and finally it makes the blood volume higher. So higher is the blood volume, higher will be the blood pressure. More is the blood pressure, more will the GFR. So we started with a problem where there was a decrease in GFR value, and we have ended in a part where we have a higher GFR value. ADH also does the same thing. ADH also increases GFR. Clear? Okay? Everybody, Shillong, Senapati, copied? This must be clear somewhat, Senapati. This is like nothing too much do with the previous sections. But yes, obviously, you will have some problems, I understand. Okay. Okay, nice. Okay, very good. Now we have seen two mechanisms. Now I just now told you that ADH is also going to do the same thing. ADH will also increase GFR. So you have two mechanisms that are going to increase GFR. Now what if the third problem you encounter is an increased GFR? What if the GFR is very high? This is again a very, very serious problem. The GFR should not be high. So I told you it's similar to increase in BP as well. So if GFR is high, you have high BP. So what now? Now see, the blood from your body, we have done with body fluids and circulation, will move to your heart. Which section of your heart? The atrium or the auricles. Now, what happens is, the atrium can sense high blood pressure and they release a factor called as atrial natriuretic factor, ANF. So the factor is called what? The factor is called as atrial natriuretic factor. And this ANF is doing what? This ANF is a factor which is responsible for vasodilation. What is vasodilation? Arteries were this earlier, this would become this. So obviously if you increase the area, you want to increase the area, obviously what is going to happen? Your blood pressure is going to decrease. If your blood pressure is going to decrease, obviously this is going to do what? This is going to decrease your GFR as well. Okay. So there was a problem in the initial, at the initial point, that was increased GFR. So once the atrial natriuretic factor comes into account, what we have is, we have a good GFR rate now. Clear? Shillong, Senapati? So these are the three regulatory mechanisms that you're supposedly going to study in this chapter. Yes, Shillong. Everybody thumbs up. Clear? Yes. Okay, very good. No explanations? Senapati, clear, everybody? Yes, children? This particular factor is released by walls of atrium. Just mention, atrium walls can sense the increased BP and release a factor. So this particular factor is released by walls of the auricles. Okay. So this is all about your kidneys, regulation, everything. Okay. We'll start up with the accessory. Okay, accessory means other supporting excretory organs. So what are the other organs you know about? Yes. What are the other organs you know about in the excretion role, excretory role? Anybody? Lungs, very good. Very good, nice. So lungs, what do they eliminate? They eliminate CO2 plus water. Water on an average rate of 400 ml per day, average. Okay? Plus, they also remove volatile substances like spices, alcohol, different kinds of drugs which are volatile, which are easily coming into the gaseous state. Very good. We have skin. So skin has two kinds of glands. One comes as sweat glands. What do sweat glands remove? They remove water, they remove NaCl, they remove lactic acid, they remove urea. Mind it, sweat glands does not remove uric acid. This was a question in NEET also. And urea. Next, what we have is sebaceous glands, the one that produces sebum, which makes our skin oily. What do they remove? They remove waxes, plus sterols, plus hydrocarbons and fatty acids. Third is liver. Yes, the main thing removed from liver is cholesterol, bile pigments, and the steroid hormones that have been degraded, that are of no use to your body now, plus vitamins, plus drugs. Okay? So all these things are removed by your liver, your skin, and your lungs. Clear? All of you? Shillong, Senapati? Yes, Senapati, are we clear? Can we move to next topic? Disorders of excretory system. So the first disorder we'll talk about is uremia. What is uremia? High amount of urea in blood. This condition is called as uremia. When there is high amount of urea in blood, this can lead to kidney failure. Or renal failure. Number 2 is obviously, talked about renal failure, we will cover that too. What is renal failure? This basically kidney starts to dysfunction. So what can be the solution to kidney failure, renal failure? Obviously we can start with hemodialysis. What is hemodialysis? The blood is purified in a dialysis bag. So what are we going to do? Sorry. We are going to take away blood from the patient through a tube. We'll put back in a particular box or a particular unit. This bag in which the blood is put, and we again withdraw it back and send to the patient's body. So we prepare a graft over here. Whenever there is this particular hemodialysis process going on, the patient has a graft over here, small graft, where we have an access to the artery and vein both. So what we do is that we take away blood from renal artery. The reason because artery has a greater, we take blood from radial artery. Radius is this particular part is called as radius. The next chapter will be locomotion and movement that encompasses this bone. This is called as radius towards my thumb. So this is called as the radial artery, the artery on the radial bone. So this radial artery, we take away blood and we put blood back in the radial vein. So we need to prepare a graft, small kind of structure over here is put permanently on the patient who are undergoing hemodialysis. So this is a cellophane bag with small pores all over, and this is the solution called as dialysis solution. If you talk about the components of this dialysis solution, it contains everything. Okay, this is a dialysis solution. The solution contains everything but not the urea, okay, except the nitrogenous waste. So this contains all components. Has all components of blood. Obviously that can come out from the dialysis bag, not the RBC, WBC and all those things, except nitrogenous waste. So better to write all the molecules of blood. So whatever chemical molecules are present in blood, they all are present minus the nitrogenous waste. So obviously what is going to happen, the nitrogenous waste is going to diffuse from its higher concentration to its lower concentration. So this makes possible so the dialysis solution gets all the nitrogenous waste from the blood into it, and at the end of the day what we have is we have a purified blood. So while you're taking out blood from the patient, you will be adding a substance called as heparin. Heparin is I've taught you these things, is an anticoagulant which prevents the blood from clotting. Okay. And when you are putting it back, you are going to put what? You are going to put anti-heparin. So that your body also has heparin, so that you don't interact both the heparins in the body. So this is one of the mechanisms in which we undergo hemodialysis. So we have discussed 3 diseases: uremia, renal failure, and hemodialysis. Clear, everybody? Did you copy? Yes. Have you copied? Clear? Senapati, Shillong? Yes, Shillong. Clear? Ah, very good. Senapati, what about you people? This must be clear. This is not so much of complex things are going on. Okay. Next is we will talk about glomerular nephritis. So what is glomerular nephritis? Wherever you hear this term TIS, understand we're talking about inflammation. So this is inflammation in glomerulus. So when there is inflammation in glomerulus, we call this state to be glomerular nephritis. This can be serious, this can lead to renal failure and death also. So it should be taken into account very seriously. Okay. Next is kidney transplantation. So what if the hemodialysis is not working for very long? Obviously we will move ahead and we'll proceed with the next step, that is kidney transplantation. So what happens in kidney transplantation? Since we know that one of the kidney is sufficient to survive, what are we going to do is that a kidney is taken from a healthy donor, transplanted in the recipient. Okay. But yes, this is not that easy as it seems to be. We have to take into account many factors. It is not that easy as it seems to be, as it might be, like at one go. But it is very difficult because there are factors you need to keep into account. What kind of factors? You need to have certain factors like there should be blood group matching. So when you are a doctor, you need to go for these steps. Apart from that, important thing is tissue matching. Like you cannot donate kidney randomly to any person. You have to have a blood group matching and tissue matching. So tissue matching is a particular process in which only close relatives have higher chances of getting pass, because the genes we share among ourselves. So more is the genetic stability, genetic relationship between the two people, that is donor and the recipient, higher is the chances of getting a successful kidney transplantation. But if it is not, it would be a much more difficult process. It will be much more difficult process, and what we need is that there should be, the patient is obviously supported with certain drugs called as immunosuppressants. This would be like a part of your syllabus in the next year. So immunosuppressants are a category of drug which suppresses the immune system. Suppresses the immune system means they make your immune system to act in a very, very slow manner, so as the kidney which has been grafted from outside is not rejected by your body. Your body does not say no to it. It has to say yes to it. But yes, there are certain immune cells in your body. There are certain particular parts in your body that you have studied, lymphocytes, isn't it? In the body fluids and circulation. Those lymphocytes, the T lymphocytes, they actually are not ready to get anything accepted so easily. So what they do is that they pose a threat to these kind of kidney transplantation, liver transplantation, whatever kind of transplantation we are talking about. But yes, the exception to the transplantation where 100% success is achieved is cornea transplantation, that is your eye transplantation. So cornea transplantations are always successful because cornea has no blood supply. No blood supply means no immunity. No immunity means no chances of getting rejected. So basically these kind of processes are taken into account before we talk about these kind of transplantation. So who is your nearest biological, from whom you can get the most Genetically identical body parts. Who is your closest biological relative? We call it biological relative. Who is it? Are you sure? Are you sure your parents are your closest biological relative? Sure. Keep into account you only inherit one chromosome from one of your parents. This gives some sense. Very good. So your sibling is your closest biological relative. You and he or she, you people share the maximum things on your chromosome. So your behavior might be somewhat different also, but yet you people are sharing maximum of the genes that you inherit from both of your parents. So a sibling is considered to be the closest biological relative. Okay. So how is your relationship with your sibling? Good, bad? How is it? How is your relationship with your closest biological relative? It's nice? Worst? Okay. Okay. That's common. If it would have been very nice, that would have been an exception. Worst, bad, these things are common. So once you grow up, you will develop a good relationship. I'm sure about it. So since you people are all in growing age, you do have some or other problems. Okay, so sibling rivalry keeps on going. We'll do some questions and we'll start a new chapter on the next day since time will not permit me to start today. Okay, so chapter is very much clear. Can we have some questions? Or do you wish to ask me some questions first? Anything which is not clear? Yes. Sinapati Shillong, solve this question. Okay, very good. So we have done this part. Very good, very nice. So we know this, that is the ADH or vasopressin is the particular hormone which reabsorbs the water from glomerular filtrate. Okay. One disease are left, very sorry. Number 6 you can mark as kidney stones or renal calculi. What are they? They are precipitates of precipitate of sodium oxalate in the soft tissues is often referred to as kidney stones or renal calculi. So people, they often ask the patient to have lots of water. So uric acid, cystic, there are many factors other than this. Calcium, sodium oxalate, there can be uric acid also responsible for this thing. We can have uric acid also, or we can also have calcium phosphate. So these heavy things, they tend to settle. Okay, these heavy things, they tend to settle down in the kidneys or other soft tissues like gallbladder, and they start to form stone-like structures, often called as kidney stones. Okay? Clear with this, children? Everybody, all of you. Are we clear? Okay, next question can we do? Okay, answer this question. Glomerular filtrate at the base of loop of Henle is, what is it? A, isotonic, B, hypotonic, C, hypertonic, and D, it is insoluble. Yes. Tell me. Very good. At the base of loop of Henle? Huh? No. Base of loop of Henle. See. Base of loop of Henle is what? Just look over the answer once again. This is base of loop of Henle. Shillong. This yellow thing is base of loop of Henle. Yes. Would you like to rectify your answer? It is 1200. It is 1200. You started with 300. What is it? Senapati, you can also try. What is it? You started with 300 and the base of loop of Henle has how much? 1200. So is it what? It is what? It is hypertonic. Okay, this is the correct answer. Clear? Sorted? you have to do these questions for the next class. Okay? Clear, everybody? Sorted? Have any doubt? Any question? Chapter is clear? Chapter is clear. So we have to start biomolecules next, is it? Okay. We're starting biomolecules. In the last class, you people told me you have to start with biomolecules first, and then you will be going with the next classes, next chapters. Okay, we'll start up with biomolecules then in the next class. Animal kingdom? Animal kingdom? Not now, isn't it? After biomolecules, we'll see if we have to start animal kingdom now or not. Okay, fine. Animal kingdom, animal tissues, and structural organization in animals. That is my section that I have to do. Rest things. Okay, we have to do animal kingdom now first. Just make me sure what I have to start from the next class. Animal kingdom. Finalize it. Just give the final name of the topic I have to start in the next class. Okay. So I will be starting with biomolecules. Is it fine? Okay, we're starting with biomolecules in the next class. Okay, just go back home and do these all things. Few of you have done it and it was very, very nice. Nice. Diagrams were very clear, diagrams were very nice, nicely labeled, everything. Very good. Keep it up. And I want to see more of answers from your side this time. And not only Shillong, but other centers also. Please do those questions and post on your groups. It would be very, very beneficial for you, not for me. Okay. It is of no use to me. It is obviously of every use to you people. Because the more you practice, the more confident you will become and more marks you will get in your exams. Okay, fine. Thank you so much. Enjoy your remaining day. Hopefully you can go and visit some puja pandal now. Okay, bye-bye. See you soon. Take care. Tata. Bye.